All right. Advent of Code, day 15. Doo-doo-doo. Uh, Lanternfish. Okay. Um, really? Oh, duh. Okay. Alrighty. Robot is facing a direction. So move all boxes. Okay. Okay. Can the robot? Okay, the robot can move multiple boxes. Great. Okay. Yeah. One from the top edge. Two, three, four. Okay. Great. Okay. Uh, the moves are going to be a little more interesting. Alrighty. Then we just need to get these moves. So, walk up. Yeah. Yeah. Okay. Okay, if I did this right. Hmm? Okay. Um, eh, well, wait, in that case. Oh, is that a new line? Oh, this is interesting. There's multiple lines. Okay. How many robots are there? One robot. Multiple movesets? Okay. Um, is zero. That sounds better. Not right. Okay. Larger example. Okay. All right. Yeah, that's wrong. Um, yeah, where in the world did the robot go? Two. Uh, that's interesting. Up from here, one, two, up to one, and it's a dot. Ooh. Okay. And now, well, at least it moved up properly. 3 R 1, 2, 3, 4. All right. Okay. Three. Okay. Let's double check. That's not 2, 2. Wait a moment. Wait a moment. Oh. Oh. Duh. There we go. 2020. Yeah. Okay. Dumb issues. Um, very, very dumb issues. Alrighty. Um, Wide boxes are that. Okay, that's fine. Yeah, okay. Left hand. Scaled up. I'm gonna want the larger example to verify. Small example. Okay, yeah. Yeah. Okay. Alright, I think generally my logic's actually gonna be just fine, which is good. Um, it's actually gonna be that now. Okay, so I'm gonna do that, then just twice as wide. Oh, dot. Okay. Now the dot items is fine. That'll be fine. That does not change size. So in theory, if I did this right, I did not. Oh, yeah, oh, yeah, because vertical. Oh, okay. This is. I stand corrected. There are some weird cases here, and it moves up, and it moves a tree. That's this is interesting. Okay. This is exactly what I wanted to do this. So I want to keep track of everything that needs to move. Okay. And do this in the reverse. Yeah. Don't care about that. I don't care about that. Yeah, yeah, I can do that. Um, Uh, I mean, yeah, it's gonna be that, or it's that. This one. Yeah. Mm-hmm. 'Do that, and then I don't need the rest of this. Where did I do T check? To check. Some typo. Hmm. 9396. Okay. That's better, but still wrong. Hmm. Yeah, something went wrong. Oh, something went very wrong. Um, right. I do this extension if okay, that's not right, but it's better. How did that happen? Oh, of course. That same thing that I that down, down, left, left, up went perfect. How did that happen? How did that happen? Oh, because of that. Okay. At the correct final position? No, but it's at least better. Actually, wait. 618. Okay. This might be right. So many moves. It didn't do it right. That is correct. Okay. So that means that something went wrong here. Which is really annoying. Yeah. Okay. I found something that went kablooey. Oh, how did that happen? This shouldn't actually happen, thinking about it. Yeah, so here I should be hitting on this. Do the extension. Okay, you know what I can do actually? I'll probably be more stable. It's a little more stable. How did that happen? Oh, actually, do that. Um, oh, okay, yeah, that's really annoying. Okay, let's go back to that and pop from 0. Probably will be more stable. Um, that is very stable. Okay, that took way too long. Okay, 156. Okay, it's okay. I would have liked to have gotten that faster. This is actually a somewhat tricky problem. So I feel like I would have had a shot for the leaderboard today, but I had a couple of tricky bugs, which is not surprising. This is actually scaled up version's a little tricky. But let me clean this up a bit. Actually, I'll leave those. Get rid of personal inputs. I do need my grid. And I believe. Okay. All right. Yeah. So let's talk about this problem. Um, this is just a grid moving problem. The real tricky thing is the fact that we've got a robot moving boxes. So instead of just hitting walls and turning, now we need to keep pushing things in front of us, which in part one isn't too bad. We've got different directions for each of the characters. That's pretty easy to handle with a map. And I do like this trick. This trick I picked up, I believe, from Code Golfing initially. Just instead of having a bunch of if-else cases, just have a dictionary with your keys and what you want. It's a temporary dictionary. Like this dict doesn't live beyond this statement, but I can still look up something here, namely the character for the move, and get out the actual X and Y deltas that I need. So that's a pretty handy trick if you've never seen that before. But yeah, as I said, the real tricky thing in part one is just making sure whenever the robot's moving, you move all the boxes that are in front of you. So to do that, I just kept looking in front until I hit either a wall or an empty space. Just just keep advancing, because I know everything in between the robot and either the empty space or the wall is going to be a box. That's all it can be. So, then after this loop is done, I just need to check, okay, so this destination I found, was it a wall? If it was a wall, can't move, so just continue. If it was not a wall, then it must be an empty space. So then I do the reverse. I walk backwards, take the source item, copy it over to the destination location, and then take a further step back. I'm eventually going to hit the robot, move the robot, and then at the end, just clear out the space where the robot was. Pretty simple. Did take me an annoying amount of time to get this right. I'll actually be interested to double check the footage and see exactly what was how long it took me to fix this. Yeah, some of the order of operations here I was getting backwards. I was incrementing the source too early. I was completely losing track of the robot. I forgot to actually move my current position where I'm making moves from. A lot of silly mistakes. Thankfully, my grid library has a print function, so I was able to debug it relatively easily, but still lost some time there. Yeah, and then at the end, just iterate through, get all the, what did the problem even call these? GPS coordinates. Get the GPS coordinates for all the boxes. Pretty simple. Then we hit part 2, where we take that same grid, but then we expand it so that the boxes are too wide, which throws many wrinkles in play. And the most important wrinkle really is right here, where as soon as we start moving up, now we move one box, and that can cascade to touching 2 boxes, which in concept could cascade into touching 3, so on and so forth, and then any single one of them might hit a wall, and that needs to then fail the entire move, as happens here. If none of them fail, then you need to move all the boxes correctly, so that then the grid state is correct. If you mess that up, then like I hit, then you're going to split your boxes, you're going to invent new boxes or lose boxes. It's a bit of a mess. So, I mean, the first part here, before getting into that complicated move logic, is just making a new grid. Instead of trying to make a fixed grid, I just went with a dictionary. For the most part, my grid library actually has a pretty similar API to a dictionary for a number of the basic operations. It just has a number of helpers as well, like printing and finding the start and all that. But beyond that, I didn't really need most of those, so I just made a dictionary, and this dictionary was going to be my new grid. And just applied the mapping. That is right here in the problem. Wall becomes double wall, box becomes a double wide box, etc. Then the tricky bit, same movement code as before, except that now I need to keep track of kind of a hierarchy. So I opted here to keep track of a set of items to move, so that I could, because the hierarchy, or rather the list of things that needs to move, gets really weird when you've got a box structure like this and you're pushing up. So I decided, you know what, let's just track that in a list. That's going to be simpler, and keep track of all the various coordinates that I need to check that are part of boxes in another list. Thankfully, I did realize as I was implementing, I also need to make sure that if I've already added a coordinate for a box that I need to handle, I don't add it to the to check twice. If I do that, other mad stuff is going to happen, and yeah, that's also going to be a mess. So yeah, beyond that, I kind of the logic in this loop was kind of similar to this backtracking here, just going forwards and just making a log of this is what I need to do. Kind of what I already just said. So if I hit a wall at any point while I'm checking the boxes I need to check, just set this flag that I can't move, break out, no need to check anything else. Otherwise, just keep a record that I'm going to move this square forward one, and then check what kind of square it was. If it was the destination was empty, then great. There's no cascading from this side. If it was one of the two sides of the boxes, then I do need to cascade. But one of the mistakes I did make at one point was I was cascading no matter which direction I was going. If we're going horizontal, then it turns out that I don't actually need this this trickery. It makes it a lot simpler to have everything implemented the same way. But if I'm going horizontal, if I extend to check the other side of the box eagerly, I'm going to cause problems. And I don't want to cause problems. I want to solve this problem. So only if I'm moving vertically, or in other words, if I'm not moving horizontally, do I then add the other side of the box to my new to check list. Because, yeah, when I'm moving horizontally, the other side of the box will get handled naturally because that is the destination in that I'm already adding, no matter what. Then at one point, I was seeing that my destination was the robot character. I think that was because I was, similar to part 1, forgetting to advance my current cursor position, current robot position tracking. Thankfully, I could comment this out later and everything was fine. But yeah, once we go through this somewhat intricate loop, took me a number of iterations to try and get this right, and a bit of debugging as is clear in the video. But once I got all this right, then it's just a simple loop over all the to move records and move them over from the source location over to the destination and clear out the source location. Now the one other tricky thing I did hit, and I believe this was the final bug I needed to fix, is this to checklist. I was popping from the back initially. And in retrospect, of course, that's going to hit issues because then I'm adding, like in this case, just take this example, or I guess technically this example. So pushing up here, I would see, okay, there's both sides here. Let me check here, or rather, let me push up. I need to add both sides here. I push this. I see. In fact, this isn't even the best example. Let's imagine that this is pushed over by 1. So actually, let's go up to here. Let's pretend the robot was here and was pushing up. So if I was pushing up from here, I'd hit this side of the box. I'd see I need to handle both of these. I would actually pop this side first, push up, get both of these, push up again on them, and all that's fine. I'd finally, at the end, pop this one, and that's where the problem would be. So I would push this, or check this last, add it to the to pushed list last, and then when I'm unwinding my to push list, I would actually handle this bit first. So I would push this up, clear out this cell. This cell is then the left side of a box. Later on, as I'm unwinding the to push list, I would push this up again, and then clear out this cell, which is then wiping out the side of the box that was supposed to be in there. All of that was a little non-obvious to me as I was writing it. It's perfectly obvious in retrospect, but that is why checking the most recently added to check item, the most recently the deepest portion of the tree that we're pushing can cause problems. Really, I need to handle everything going, like if I'm pushing from here up, I need to handle this whole row first, and then I can start processing this row. Because ultimately, when I'm unwinding my move stack, I need to truly move these at the end. This whole row first, then move this row, then that row, etc. So hopefully that explanation makes sense. It's a little tricky. That's why I missed it live. But yeah, once all that was done, then we've got just the same summing as part one. Just find the boxes, get the GPS coordinate, add it to the answer, and there's our answer. So yeah, I scored what, 156? Yeah. I'm a little curious. How far was I from the leaderboard? 3457. Oh, not far at all. Not even 3 minutes. Yeah, so if I'd been just a little faster on that bug, I would have leaderboarded, but it is what it is. I have 10 more days to try and leaderboard, so hopefully I'll be able to manage it. Anyway, that's all I have for today. I'll be back with tomorrow's problem.